Yes, my name is Richard Yonk. I am, as Evan said, I'm a writer for various publications about emerging technologies, and have recently completed a book on the topic of today's talk, Heart of the Machine, Our Future in an Age of Artificial Emotional Intelligence. There's a lot of information in this, and I compressed it down to an hour, and turned out we have a half an hour, so I've compressed it again. So just to let you know, I'm going to be shorthanding a lot of this, and there is a lot of opportunity to talk with me after the session if you want. If there's time for a Q&A at the end, I'm happy to, but I know that this is a really smart audience, so I know I can shorthand a bunch of different aspects about it. Emotional interfaces, effective computing, social robotics, artificial emotional intelligence. These are technologies that are going to transform our society over the course of the next few decades. They are going to bring about many new ways for us to interact as individuals and as a society. They are going to bring many new opportunities, new ways of doing things, new ways of interacting in our environment. But at the same time, they're going to bring many new challenges and problems that we are going to have to face and address in the course of this new era. Now, in addition to this, I believe that artificial intelligence is going to actually be bolstered by some of the advances being made within this field, that it is in some ways actually establishing some technologies that are going to be necessary in order for AI to be able to exceed a certain, call it a glass ceiling, a certain threshold, because of how we rely on emotion in the course of our processing our intellect. In order to be human level or even beyond, it may actually be necessary, as we'll find out in some of the later part of the talk, for AI to actually have an emotional component or an analog thereof. But that is still years down the way. A little earlier this week, I had an opportunity to hear a talk by Jim Dator, and one of the things that I took away that he said that I loved was, you have to know the past in order to be able to explore the future. So I'm going to really take him at his word today. We're going to start 3.5 million years ago. This is when Australopithecus was well established on the planet already and had just begun to use and make stone tools through a process known as flint knapping or stone knapping. This process is really quite amazing, but I chose this moment because this is an amazing period in our life, in our time as a species. This is the instant, this is the moment when we became a technological species. This is the time we began this long journey with technology, a very, very successful journey, to essentially co-evolve and support each other through these 3.5 million years. Now, it's a very interesting thing about stone knapping. People think of it as just picking up a couple of stones off the ground and knocking them together, and it is not. It takes a lot of practice. It actually takes hundreds of hours of practice for a Homo sapiens to become proficient at it. But it was such an important part of these hominids' existence in order to survive, in order to improve and change their diet, that it carried on for 3.5 million years. But it literally takes hundreds of hours to learn, and in the course of that, it rewires us. It changes our brains. A study that was published in Scientific American earlier this year looked at scans of people who practiced literally hundreds of hours of stone knapping in order to learn how to put an edge on a stone in the fashion that our early hominid ancestors did. And it literally changed their brains. It created many, many new neural connections in their visual motor cortex. It added new connections in areas connected with learning, attention, self-control, and even speech. Now, this is a very cool example of how technology literally changes us, as opposed to how we talk about it in terms of its usage. This is the actual making of it. Now, as successful as it was, we have to ask ourselves, 150, 200,000 generations. This is passed along. And yet, these hominids did not have what we think of as speech. It's generally considered that, from a communication standpoint, they had the equivalent communication capability of a modern-day chimpanzee. So how did they pass this information along? They passed it along through primarily animal communication, which is essentially declarative and emotive in nature. This is a technology, a technique that is not just simply a matter that you can mimic it. You actually have to be mentored, and this is obviously not a species that is at the level of Homo sapiens. So this would have been a very ritualistic process that would have been transferred generation after generation. Now, emotion is an extremely complex process, and it affects us in many different ways. Internally, externally, how we interact and relate with those around us, how it prepares us to be able to deal with different type situations we see in our environment, but it does several other things as well. As we're going to talk about in a little bit, it directs and mediates intellect. It's a major part of our communication repertoire. It was totally then, but it is, even now, it's still a very, very major part of how we communicate. We didn't just put it away and leave it behind. This is part of how we interact with one another. And finally, to talk a little bit about how it interacts and contributes to certain aspects of consciousness. Consciousness is something that often is talked about in a rather large and amorphous way, that it's one thing, but it's actually many different things. There's the aspect of phenomenal consciousness, otherwise known as qualia, access consciousness. These are categories that philosopher Ned Block has talked about. But there are other areas such as introspection, self-awareness, theory of mind, that emotion easily could have been part of the contributing process to bringing about. Now, this sounds like we're starting in a very, very early day because this is an essential view from our standpoint of what we can project onto technology. Now, over the years, I've talked about and written about interfaces at some length. And in exploring this, one of the things that I've found is that a lot of people think mostly about interfaces in terms of technology. They think of it as the handle of a shovel, the steering wheel of a car, the keyboard of a computer. But emotion and speech were very much interfaces as well. In so many ways, emotion was our very first interface. And this was how we interacted with one another. Many years ago, technologist Brenda Laurel wrote that the greater the difference between two entities, the greater the need for a well-designed interface. And this is why, over the years, we have needed more and more complex interfaces for our technologies. But what you notice over more recent years, as time has compressed in relation to exponential progress, is that there's been a progression. We've moved from computers that needed to be hardwired, to punch cards, to command line interfaces, to in the 80s and 90s we had graphic user interfaces, and today we're starting to get into the period of natural user interfaces. These are gesture recognition, touch screens, speech recognition, and all of these are a trend toward our wanting our machines to interact with us in a more and more natural way. And emotion is going to be one of the next one of these, because we want ultimately our machines to connect with and operate on our terms, not the other way around. A number of years ago, Clifford Nass has a theory. He's a communications professor at Stanford University. He has a theory about media equation, and he wrote a book along this line. And essentially, he says that our relationship to technology and media is primarily social, primarily natural. And this is how we want to interact with it. We actually tend to interact with our machines to a degree as if they are people. It's just the nature of having an interaction. It's how we evolved. So it's going to be a trend that we're going to want to see our machines, since we have the capability computationally, we will want to see our machines interact with us more and more in this manner. Now, over the years, I hear people talk about we're becoming more and more like our machines, we're becoming too dependent on technology, and it always makes me smile a little bit because the reality is just the opposite in my mind. We are actually making our machines more and more like us. They are trending toward working more and more on our terms rather than the other way around. So this brings us to a point early in the mid-90s when Rosalind Picard at MIT Media Lab was working there. She's an electrical engineer, very talented woman. She had done a bunch of pioneering work in AI at that time, including AI vision systems, some of the precursors to Google Image and so forth. And in the course of her work, she was finding that she felt that her systems should be working better than they were. They were brittle in certain ways. They were not functioning or they were failing at times she didn't feel they should. And when she thought about it and looked at the problem again and again, what she came to the conclusion was that it was a matter of attention. These systems knew how to find a line, how to find a shape, but they didn't know where to place their attention. Should they be looking over here or over here? And so she started talking with a lot of neuroscientists and different people and came to find out that the systems she was looking at, vision, learning, memory, all of these, at some level or another, tie into emotion. So this was it was revelatory to her. She was fascinated by it, but at the same time she was very concerned about what she was finding because this was the early days for a woman to be in a very male-dominated field, and the idea of being connected with something as, quote, irrational as emotion was not a direction she felt that was going to be good for her career. So anyway, eventually she did publish, but in the meantime she was gathering information, and this is just one example of a case. I have to really shorthand this a lot, but this poor gentleman, back in the 80s, he had suffered from a meningioma. It's a benign tumor that essentially had to be operated on rapidly or it would have destroyed his brain. But in the course of it, they took out the tumor. It was a successful operation. He still had his intellect. He was a high IQ individual to begin with. Still had all of his intellect, all of his memories. But what was very interesting and sad for him was he could no longer make a decision about the most basic things in life. In addition to this, he was totally emotionally flat. He didn't seem to have any emotions anymore. And what it was determined after a lot of tests and scanning was that he had essentially been cut off, his higher cognitive functions, his prefrontal cortex, had been cut off from his bodily experience of emotions, where our primary emotions begin. The endocrine system, the sympathetic and parasympathetic nervous systems, our limbic systems, all of these interact in a way that over time, through the years of evolution, they gradually became integrated with our higher functions, and we began to have a degree of top-down but also bottom-up influence from these. And it turned out that his inability to access that information seemed to have the effect that he couldn't distinguish value in his environment. The idea that this might be worth more than that to him. And we do this literally thousands of times a day in the course of our day-to-day routines. So I'm happy to race through this, but essentially, in short, this indicated, as well as did other information that she was finding, that essentially this was essential. Emotion at some level was essential to being able to think and have thoughts, cognitive processes beyond a certain point or a certain level or type. So her work, she created the book Effective Computing, started an entire new branch of computer science as a result, launched the MIT Media Lab, Effective Computing Lab, and that was very prolific. There were a lot of people there who put out a lot of good work. It's a field, and there are many modalities, essentially, to look at when you're considering emotion. Emotion, we can read it on people's faces, we can hear it in their voices, we can see it in their gestures and their posture and everything else. And these research associates were looking at all of these different ways that this could be utilized. And believe me, there's a lot more than this, but it gives a little bit of a sense of how many different ways effective computing can essentially look at the human condition. It's multidisciplinary more and more these days. Consider that you're not just necessarily reading emotion on a face. You may be using an algorithm to create an expression on a robot, or to provide effective, provide some emotion in a voice. Something like that. You can use it to model future behavior of an individual or an aggregate group. There's just a really, really wide breadth that this field can take. So, 2008, 2009, Roz and a research associate, Rana El-Kalioubi, who had come from a PhD at Cambridge, where she had actually made one of the first emotional prosthetics that helped with face blindness. They started a company called Effectiva. It was originally going to be for emotion analytics in more general terms, but it ended up focusing mostly on facial recognition, facial emotion recognition analytics. And in doing this, they were motivated by the fact that they needed bigger and bigger training sets for their deep learning algorithms. Deep learning is something that the more data you can throw at it, the better it gets. But they had gotten to a point where they couldn't generate enough of this anymore at the Media Lab. They had to literally go commercial in order to be able to have the material that they needed to keep making their systems better and better and better. So when I talked to Roz a couple of months ago, she told me that, in fact, if they had to continue doing the process at Media Lab the way they had to generate the level of training material that they had for their systems after this company, it would have cost them $1 billion, literally, to do that. And obviously that wasn't going to happen. So it's a really interesting confluence of the commercial market and a new startup and a new technology being at the right place and at the right time. Here's just a real short example of how the face gets mapped. It tends to, a lot of these companies doing facial mapping map it according to a taxonomy that was developed by Paul Ekman in the 80s and 90s. And essentially it's the machines can actually read well enough that even if you try to mask, even if you try to hide your emotions, they can actually detect what you're feeling. There are other fields and other focuses. Beyond Verbal, out of Tel Aviv, works on voice analytics. This has nothing to do with language, nothing to do with word and sentiment analysis. They literally are listening to the vibrational qualities of the voice, and in working out their algorithms and training this, in talking with their chief science officer, he told me, it took a little while convincing, but I'm much more convinced now. He told me that out of 174 countries, there was only one country that skewed a little bit aggressive, but for all the rest, they could literally, after 13 to 15 seconds, pull out the person's emotional state and even a few aspects of their personality. A lot of big companies are starting to get into this. Apple bought Emotion, another facial emotions recognition company, early this year. Intel has been working on their RealSense system, which they want to imbue with some degree of emotional awareness. And Dell has announced that they want to have a few systems that have at least some degree of emotional awareness as early as 2017. So the military has been very interested in some of these fields. Obviously, PTSD has been a big issue, and the ability to either treat it through different methods or to be able to even anticipate it or prevent it is obviously seen as an important thing. The Air Force's 711th Human Performance Wing has done a bunch of work with transcranial stimulation, in which they have taken and worked on trying to improve attention, trying to improve rates of learning. They've had some pretty good success. They actually, in a few of their tests, they showed a 300% increase in rate of learning, which is really significant. Socially assistive robots. Robotics is obviously a field that people tend to associate emotional computing with more and more these days. As we've heard in a number of the talks during the course of the conference, there are a number of countries, developed countries, industrialized countries, that are seeing aging populations, and they're needing to be able to deal with that shortfall. And so one of the approaches, in the case of Japan, for instance, is to make major investment in robotics, and a big chunk of that is going to working on emotional awareness. So you've got the idea of robotics that are helping in hospitals in various functions. That's RoboBear up in the upper center. You've got social companion concepts. You've got different tasks that people are being helped with. And it's also being used in education, also being used in things like autism detection. But the thing is that these are all, because these are people that did not sign on to work with robots. It's not like in the 80s and 90s when some people actually had to start working with them in their workplaces. These are people that their life has been, probably turned upside down in one respect or another. They need these robots to be emotionally aware. So there's the recognition that we need to be able to build this more and more into these systems in order to make them help us out in more and more ways. I'm really going to skip ahead here. There's a number of aspects about the impact of robotics on what Sherry Turkle calls our Darwinian buttons, but I'll skip that for now. Different aspects of downsides that can happen, commerce. Obviously, there are a lot of good ways this can be utilized. It can be used to help with the shopping experience, to improve a number of different ways that consumers can interact with companies and with products. But at the same time, I think we have to be aware of and careful of things like predatory marketing, predatory sales, which I consider, I'm going to have to elaborate on that just a smidge. If you have an AI system, if you have a robotic system that is able to read your emotion instantly, second by second, while you're in the midst of a negotiation with it for buying a car, for getting a raise at work, you are not going to come out anywhere near as well off as if you were interacting with a human being. So that's what I mean by predatory in that sense. You've got the potential use by despotic regimes. You've got different aspects of the gray and black market. Hackers for social engineering would find some of these abilities rather useful in their toolkit. So finally we get to AI, and I'm running out of time, so I'm racing through this. This is where this all comes down. In so many ways, we have been exploring this issue, this problem of AI, what it's going to mean as it reaches a certain level in terms of it reaching human level intelligence, potentially super intelligence. Is it going to be an existential threat? What is it going to mean? And I'm of the opinion that in order to get to that point, it may actually be necessary, based on some of what was said about focus and these types of things, for AI to have an emotional component, an aspect of emotion, an analog thereof, in order to be able to achieve that. So it knows where to place its focus. So it knows what has different value in its environment. Now, that said, there may be reasons why you'd say, well, why would we even want to do that? But we also have to remember there are a lot of systems out there that aren't really anywhere near human level yet that could really benefit by emotional awareness, because they control our systems, they control our infrastructure. So, for instance, if you have a jet plane that is flying and is getting ready to crash, you want your AI that's running that system to be as afraid as the passengers are, because you want it to just work its butt off to try and keep that plane up in the air or get it to a place where it can land safely. So essentially you want the AI to have it align its motives and its values with that of the human race. Now, that said, I think there's a lot to be said for the idea that there are reasons within the different substrates that we have that this may not be possible. What we do within silicon may not be possible with what we do within biology may not be possible within silicon. It may not be possible for an AI that is silicon-based to experience the endocrine system, the sympathetic and parasympathetic nervous system that we have that lets us feel the hairs raise on the back of our neck, the palpitations in our heart, the butterflies in our stomach. It may not be feasible for it to do that because it's not biological. So how do we do this? Well, perhaps in the interest of we've talked over the years about gradually merging more and more with our technologies, not becoming our technologies, but having our minds be able to access information more, be able to improve and increase our processing, access different aspects of the web and human knowledge and human interaction. What if we turn that around? What if we say, okay, why don't we give the AI access to a little bit of information from us? Literally, what it is to experience these types of feelings, essentially. The bodily experience of feeling to help it model and be able to move up to a certain way. So it essentially is keeping its motives, keeping its priorities, keeping its values in line with our own. This is something that we call this bonding. This is something that we do within society among each other. We do it even with other species in the form of pets. This is what has kept our species from killing each other over all of these many, many millions of years. We bond together because we have like values. We have like understanding and views of the world. So I am hopeful that if we approach this in certain new and creative ways, that perhaps we will be able to continue this long and very, very fruitful and successful journey that we have been on with technology for many, many more millions of years. Thank you very much.